Okay, so this is going to be mass in the mole. I'm going to go over our strategy for solving these problems. Now, I gave you some steps before. There were 4 steps basically to solving any of these problems. But now that we're kind of adding to it a little bit, I kind of want to put in a new step at the beginning. So whenever you get one of these like word math problems that we have to do, whenever you get those, the first thing you want to look for is the units involved, okay? So the first thing you look for, what I would do is I would look for is mass or grams or G, is any of that in the problem? Because right away, if I see that any of that is in the problem, that tells me that the tool I'm going to use to convert is going to be the molar mass. So I'm going to have to find the molar mass right away and write that down somewhere so I have that available when I'm solving the problem. The molar mass, again, that's what you look at the periodic table for. So you take the element or the elements that are in the compound, and you'll find those on the periodic table, and you'll write down that mass, and that's how many are in 1 mole. And that's the tool you'll use to convert on any problems that involve mass or grams. Same thing. Yeah. All right. The second thing to ask is, are particles involved? And particles, you might see it written as particles, you might see it written as atoms, you might see it written as molecules, you might even see things like formula units. Now, this first tool over here, we got to know the substance. We got to use that because we got to look it up on the periodic table. For this one, for this type of problem that involves particles, atoms, molecules, formula units, whatever, we don't have to look at the periodic table. We just use 6.02 times 10 to the 23rd particles, atoms, molecules, formula units, whatever it is, per 1 mole. And that's our tool for solving those problems. All right? So right away, when we look at a problem, find out what kind of problem it is. Does it involve mass? Does it involve particles? Does it involve both? All right? So that's going to be our new first step. After we have this taken care of, then we can just go through our regular steps. So, and a little hint on this sheet, you see that it's all mass and the mole. So they are all this type of problem, which makes it easier. We don't have to really identify what type of problem it is, but it is a little more work because we have to find out the molar mass from the periodic table. So I want to do a couple of examples from your worksheet here. I'm going to start on the back side since we did some on the front side yesterday, but this is number 15 on the worksheet. And it says how many grams. Okay, so like what I just said, right away you see grams are involved in this problem. Whether they're asking us to find grams or whether they're giving us grams, grams are in the problem, so I know I got to find molar mass. So right away I want to find the molar mass of this substance. The substance is NaF. So we know that wherever we see a capital letter, that's the start of an element. So I'm going to look these up on the periodic table. If I look up Na on the periodic table, check that. We also got to pay attention to what's in it and how many atoms. So when I look at this formula, I see Na is in it, and there's no number after it, so it's just one time. And then I've got F, and no number after that, so just one time, so just one of each. So if I look up Na on the periodic table, it has a mass of 22.99. If I look at fluorine on the periodic table, it has a mass of 19.00. And so I'm just going to add those two amounts together. And so the mass of 1 mole of NaF is 41.99 grams. So this is going to be my tool for solving the problem. So now let's actually solve the problem. All right. So when we write our equation, the first thing we do is we write the start. That's what's given to us in the problem. On number 15, it's 4.5 moles of sodium fluoride. So I'm going to write 4.5 moles. That would be good enough, but it's never a bad idea to include the substance formula. What is very important when you write your start, don't just write the number. Make sure you include that unit. Okay? The next thing I'm going to do is I'm just going to write my times in line. And the reason why it's so important to write that unit in your start is because that tells you what to put under the line. So now I'm just going to plug in my tool. My tool is 41.99 grams over 1 mole. This tells me that moles have to be on the bottom, so it tells me the right way to use my tool. Do I use it the way it's written, or do I need to flip it upside down? If I use it the way it's written right here, grams will be on top and moles will be on the bottom. And as we can see here, we want moles to be on the bottom. So I'm going to leave it the way it is. And so the moles cancel out. So I see that the bottom of this equation is just 1. The top is the only thing that has numbers in it. So obviously in this problem, I'm just going to take 4.5 and multiply it by 41.99. So if I take 4.5 times 41.99, it's going to come out to be 188.955, something like that. I'm just going to round it off to 189. And the units are grams. And that's how you solve it. So we do know on each of these problems on this worksheet, they are mass to mole problems. So we got to do the molar mass for all of them. Okay. So number 16, like I just said, I know I'm going to have to find the molar mass of all of them. If I read the question, how many moles are in 98.3 grams? So they're giving me grams, so it's a mass problem. I got to find the molar mass. Now the formula here is AlOH3 in parentheses. So it's this. So when we find the molar mass, let's write down what's in it. I've got Al, and Al is not in parentheses, and there's no number after it, so it's just 1 time. And then I have O. Now remember, when you have something in parentheses, look at how many of those atoms are in the parentheses and multiply it by the number outside. So in the parentheses, there's 1 atom of oxygen. So I got to take that 1 atom and multiply it by the 3 outside. So there's actually a total of 3 oxygens in this molecule. And then the next element is H, and same thing. There's 1 of them inside the parentheses times 3, so there's actually 3 of them. So I'm going to look at the periodic table now, and I'll see that each aluminum atom has a mass of 26.98. And there's just 1 of them, so it's 26.98. Oxygen, each oxygen has a mass of 16. But if there's 3 of them, I got to do 16 3 times. So it's going to be 48. And then hydrogen's mass on the periodic table is 1.01. But there's 3 of them, so it's going to be 3.03. So now I'm going to add up all those numbers. 26.98 plus 48 plus 3.03 comes out to be 78.01. Is that what you guys got? So there are 78. So there are 78.01 grams per 1 mole. And that's the tool I'm going to use to solve this problem. So now let's write our equation. Step 1, identify the start. They're telling me that there is 98.3 grams of this. Write times in a line. And so if I started with grams, then that means grams goes down here. So if I look at my tool the way it's written with grams on top and moles on the bottom. But as I can see here, I want grams to be on the bottom. So I'm going to flip it upside down. Yep, so 78.01 will go on the bottom, and the 1 mole will go on top. And that cancels the units. So now I see I've got a number on top that I got to use and a number on the bottom. It's going to turn into a division problem. On the top, I have 98.3 times 1, which is just 98.3. We do have units up there, moles. On the bottom, all I have is 78.1. So there's our division problem. 98.3 divided by 78.01. Yep, that sounds right. So it comes out to be 1.26 moles. And that's how you do it. All right? So all of these problems you do are either going to be like 16 or 17. You're either multiplying by the molar mass or dividing by the molar mass. But it is very helpful to know how to set them up right. I do want to just do one last note. On the last 4, they use scientific notation. Just a reminder, if I take some number that's in scientific notation, so I'm just going to make easy numbers. I don't really have to use my calculator. Let's say you've got 2.0 times 10 to the 5th, and you got to multiply that by 3. Okay? So all you do, take the normal part of the scientific notation, the normal front part, and then that normal number, just multiply them normally. So 2 times 3 is 6, or 6.0, whatever, same thing. And then just add this times 10 to the 5th part. Okay? If you're dividing, if you've got something like 4.0 times 10 to the 6th divided by 2. Same thing, take the normal front part, divide it by the normal number. So 4 divided by 2 is 2, but don't forget to put the times 10 to the 6th after it. All right? So that's it.